socially acceptable for men to be salt and peppery.
Screw social norms. Alright. Oh, okay. So, what do you mean? Something like... You can do it. Yeah, let's see if this works. How's that? So how do you do this? Yes. So 1, 2, 3. 1, 2, 3. And now you just go to town, right? That's the idea. And I'll tell you to round it to a certain amount of decimal places if I know it's going to be one that goes forever. You guys with me? Is that cool?
Yeah.
And then, so 9 goes into 41. Four. 57. So the thing to be careful about is you put the decimal there. So it does completely matter where you put these numbers. You have to be careful about how you put them because it's going to change where the decimal goes. The decimal should go right above it as long as you put these numbers where they're supposed to go. I don't want to do more of that problem. You guys know how to long divide, hopefully. 9 goes into 57. 6. 4. 39, right? 9 goes into 39. 4. 36. You bring down 7. Alright, so this one I have to tell you. Yeah, so now it's just 4. 36, might go 1, 0. 1, 9, minus 1, 0, 1, minus 1, 0, 1. Yeah. So, yeah, I like
Stuffing things and stuff.
Is that right? I mean, yes. Maybe. Is that cool with everybody?
Yeah.
So either I'll tell you to round to a certain place, or it's one that will have like a repeating thing. So you just have to. Yeah, that bar means keep going forever like this. Yes. Okay.
I have a question on 563. It's 264.
No.
So while that thing's warming up, what's the problem, say?
It's 5 over 16, parentheses, 117.6, close the parentheses, plus 2 and 1/3, and parentheses 699.
Like that. Okay. Yeah, let's scroll. Okay, so this is section 5.3, is that what you said? Okay. Someday this will load. As always, when I'm about to do a problem, I double check to make sure it's the actual right problem.
So when you're, like when you have two fractions that you're adding together, right, you're getting to the least common denominator. If there's a whole number with it, you have to multiply the whole number as well, or no, right? It's just the fraction, obviously. To get the fraction in my mind.
Yeah, we'll do an example like that.
Alright. Just make sure I'm not.
You're probably losing your mind, but not because of that.
Solid response.
What was it? 264. Okay. Give the answer as a decimal. All right. So it's 17.6. Yeah. Okay. Cool. Oh, 5/16. Right. Okay. All right. So you ready? All right. Now watch. If I was going to make you do this by hand.
Say that again?
All right. If I was going to make you do this by hand. Yes, I know. So you should be ready for that. What am I doing to 117.6? What does this want me to do to it? Like I'm multiplying it by 5. And I'm also dividing it by 16. So I can actually do 16 into this as side work. So let me ask you, how would you do 7/2 of 10? What would you do?
Like put 2 with the.
So 10 divided by 2 is 5.
Times 7.
So then you can put that there, and then so what am I going to do? I'm going to do 16 into this.
Yeah.
Whatever answer I get, I'm going to multiply that by 5.
Yeah.
Whoa.
Mind blown.
Same thing you would do over there. Same thing. Because what does 5 over 16 mean? The 5's on top, so it wants to multiply by 5. 16's on the bottom, so it wants to divide by 16. So let me divide by 16.
Let's do that.
Let's try. Let's see. What happens? Yes?
So you're saying you divide the whatever in parentheses times the top number and divide that by the bottom?
Yes, and I want you guys to understand this is exactly what we always do. That's what you do. So again, if I had 11 over 18 times 36, wouldn't you first do, I hope to God you would do this. 18 goes into 36
Done.
twice. Okay, so what am I doing? 16 goes into 117.6. I don't know, let me figure it out. And then I'm going to put the answer there. Right? So 16 goes into 117.
7.35.
All right. But how did you do it long division? Okay. And did it stop at 5 or what? Oh, you did the calculator. Okay, that's no good. All right. So I mean, you would do this division, and then you would multiply what you get by 5, right? I don't know why I keep putting it there. 16 goes into 117 about how many times? So again, I like the little side work I see. 16 times 5 is 80. 16 times 6 is 96. I really want this to make sense. 16 times 5 is 80. Is everybody cool with that? So 6 16s would be 96. One more 16 beyond this. So 6 16s would be add 16, 96. 7 16s would be add 16, 112. So it must be 7. Let me stop there for a second, yes?
Okay, so you're not gonna like put like a 1 over that number and then.
Oh, sure, you could if you want to.
And then like multiply across.
I could multiply by 5 first, but I'd rather not. Right? Just like here, you could multiply by 11 and then divide by 18, but why would you? Why don't I make the number smaller?
Because I put 3 places and I ended up getting it wrong.
Okay. There's nothing wrong with multiplying by 36 first. It just makes a huge number that you then have to work with. So in general, it's better to make that number smaller first, right?
Okay, so if we did my way.
Then you would do 5 times 117.6 and make that number bigger.
Can I make it smaller?
Not if you multiply by 5 first, that's going to always make it bigger, right? If you multiply by 5, it's going to make it bigger. I'm not sure what your question is.
Multiply the 5 by whatever we come out with the
Exactly. That's right. Exactly. Same thing you would do here.
Right.
Multiply the 11 by whatever you
So
get
where's that
there.
decimal going? Do we
Maybe.
move that over or does it stay there?
What's up? Oh, okay. I'll get it in a minute.
That's
So then 7 times 16.
17.6. Where's that point going?
Well, it's going to go right there now, right? Because I put my 7 in the correct place. I put that 7 over the last digit in the number that I actually went into.
Right.
So that's what I mean by lining it up correctly, so you know exactly where your decimal's supposed to go. So pretty cool so far. All right. That's 1/12. The 7 times 16 is 1/12. Then I bring down to 6. 16 goes into 56. 3. I like it. 48. Subtract.
8.
And then bring down to 0. Oh, yes, it goes in. Yeah. And then 16 goes into 80. 5 times. So I'm done. That's 7.35. So just like, now, why didn't I have to do this here? Because I know 18 goes into 36 twice. So then what did I make this problem become? I made it become 11 times 2. So what did I do? I did the side work for this. Now I'm going to make this become 5 times 7.35. It's nothing different from what we did before. It's just uglier numbers. So I had to do a little more work in the middle. Yes?
I don't know why, but like instead of putting a 1 under the number, I put like a 10.
Well, then don't. But see, if you put a 10 under it, you've changed the problem. You can't just put a 10. Why am I allowed to put a 1 under anything? Because dividing by 1 doesn't change it. It leaves it the same. You with me? So why am I allowed to multiply the top and bottom of a fraction by the same thing? Because it leaves it the same. So I'm allowed to do anything I want to in the universe as long as it actually ends up leaving it the same. It just makes it look different, but it actually leaves the value the same. I like it. Now if you put a 10 over there, then you've changed the value of it, right? All right, now continuing, how am I going to do this piece? Well, hopefully I gave you some inspiration. How do I write 2 1/3 as an improper fraction?
7
Yeah. So now I've got, here's my side work. So now I've got 5 times 7.35 plus 7/3. So what do you think I'm going to do here? And look, 3 goes into 699 easily. Thank the gods. So I got 5 times 7.35. What's that 7.35? Oh, it's this here, right? So I've just rewritten the problem, just simplifying a part of it, which is the whole idea of simplifying a numerical expression in the first place. Replace this with a better looking thing, with what it actually is. 3 goes into 6, 9, 233. So now it's plus 7 times 233. And I'll let you guys finish. Just multiply that, and add them together. PEMDAS, when is it true? When is PEMDAS true? Always. Right? It's not just, we're not out of the PEMDAS section. You're always in the PEMDAS section because it's the grammar of math, right? I like it. So, in fact, it's even more than just grammar, because grammar, you can twist it. If you're just with your friends, you talk a different way than if you are talking to your teacher or something. Here, you talk the same damn way no matter who the hell you're looking at. You use the grammar always the same. Otherwise, you get a different answer than somebody does. Yeah. Is that cool? So thankfully that this went in evenly and that went in evenly. It's not nearly as ugly as it first looks. It's not pretty, but it's something you can sink your teeth into. Yeah.
Okay, for the same section and number 220.
220? Now I would tell you what form I would want the answer in, but here we're in the decimal section, right? So I know I want my stuff in terms of decimals. Somebody help me out. How would you write 17 over 100? How would you write that as a decimal? How would you write 17 over 100 as a decimal?
0.17.
Yeah, 0.17. Is that cool? Because I want to go out to the hundredths place So I need tenths, hundredths. There you go.
Yeah.
What's the point here? Well, that's 20ths. 20ths ain't got nothing to do with my decimal terms, right? But I can certainly make that become hundredths, couldn't I?
Yeah.
If I can make a fraction become over 100, or over 10, or over 1,000, I can make it into a decimal easy. Because that's what decimals are. So how do I make this become over 100? That would be 200. How to make it over 100?
You add a decimal in between the two.
No, we're overthinking it. What do I multiply 20 by to make it become 100? By 5. All right, so do the same thing to the top and the bottom. Now, again, we're in the decimal section, right?
Yes.
So more than likely, they want the answer to come out as a decimal,
Yeah.
right? I think this problem, did it say... It just says simplify the expression. Are you with me? But we are in the decimal chapter for this problem. So I'm pretty sure they want me to have the answer as a decimal. Now on the test, I'll have to tell you because it's going to be kind of mixed up. So what do I have? So I got 3.9 plus 45 over 100. But what's 45 over 100 as a decimal? You can do it. 17 over 100 was 0.17. 45 over 100 is 0.45, yeah. Tenths, hundredths. Ah, there you go. 2 zeros, 2 places. It's crazy, yes.
So what I did was I changed the decimal into fraction.
All right, and do you understand why that's okay in general, but we're in the decimal section, right? So they probably want the answer as a decimal. But if you do that, let's see what we get here. How do I add these? 0.45. If you want to put a 0 there, you can. I'm just adding, so that's good. So you get 5, 3, 4.35, right? Now, Jackie, how did you change 3.9 into a fraction?
Well, I put it under 10.
Be very specific. What did it become?
3 and 9 over 10.
I like it. Okay, what did you do from there?
And then I multiplied, and then I added.
So what did you get there?
I got 39 over 10. And then I multiplied 1 divided by 2 to make it 20 because the denominator is the same. So then I added 5. And then I end up with 4 and 7 over 20.
So you get 87/20ths, right?
Yeah.
4 and 7/20ths. And guess what 7 divided by 20 is?
I don't know.
0.35.
So it's wrong.
No. The answer you got is the same answer we got.
Change it to like a decimal instead of a fraction.
Yeah, again, since we're in this decimal chapter, they probably want decimals. The work you did, I don't want you to feel like the work you did was wrong. The work you did was right,
But it's wrong for that.
but they didn't say. Actually, they didn't really say in those directions, but it is the decimal chapter. They more than likely want decimals to be focused on, right? So you want to convert that fraction into a decimal. So in the test, I would say, simplify the following, leave your answers as decimals, or I'd say leave your answers as fractions, so you know which way to go.
So without the decimal, it would be wrong, or you'll just take points.
If I said leave your answer as a decimal, and you give me that answer, you're going to lose some points. You're not going to lose all the points, because if you did all this work, it's pretty good work. But you're going to lose some points because you didn't do what I asked. Yeah. Okay. Yes.
Where the 5s come from? Is that just to like make it easier to work with? How about that?
Yeah, I know, but the whole idea, if I can make the bottom some multiple of 10, then it goes into a decimal exactly, because that's what decimals are. They're bottoms of 10s, powers of 10s, right? So 9 over 20, that's not point anything, but 45 over 100 is 0.45. Yeah. So if you did 9 divided by 20 in your calculator, it'll tell you 0.45. Yeah. So how would you make, what would 7/5 be as a decimal? How would you make that into a decimal? You could do 5 into 7, but I'd rather just make it over what? Even better than 100. 10. You just need to make the bottom some multiple of 10. So how do we make the bottom 10? So this would become 14 tenths would be 1.4 tenths, right? 14 divided by 10, the decimal would move back 1.4. I like it. But there's nothing wrong. If you did 5 into 7, we'll get the same answer. Right? 1, 5 minus equal 24, 1.4 done. So either way is fine. When do I want to definitely do this? When the bottom can't become some, like the bottom was 7. Screw that. Can you make 7 become 10 easy? No. 100? No. 1,000? No. Screw that. I'll just divide it. Does that make sense? But if the bottom is 25 or 20 or 50 or 2 or something, hell yeah, I'm going to make it become 10 or 100 or whatever. But will this way still work? Of course it will, because that's what this means. It means divide. So you have 2 different ways to do it based on what you can think of at the moment. Okay. Yes?
I have a test.
Say again?
I'm a test. I was recollected.
You have your test corrections? Oh, in your bag. Okay. So you guys, where do we want to go next? You might as well just join your class. Look at that. Check with admissions, see if we can get credit for that class. This year? Your corrections? They're in here somewhere?
Yes, and yes, I need to.
Oh, they're on the paper. Oh, I see. Okay. And quiz 3. Oh, this is just you practicing stuff. Okay. Homework? Is this homework ready to be turned in? Looks like that one's done. Almost. I'm gonna let you hold on to this yet, because it looks like it's not quite done yet. It's not due till Thursday anyway. Okay. So you got your test corrections. I'm gonna put an answer key in here for you, buddy, for the practice test. All right, guys, where are we?
All right, Jeff, here's one. This is off the practice test. Are you
All right.
Put that up later, or you want to do it now?
I want to do it now.
Okay, this is up in number 1. It's 0.2.
Where are we at? Which one?
Number 1, F.
F. Okay, gotcha.
In the page on the down.
Say again?
Down.
Down. Where might it be? In the back? No. I don't see it up here, brother. Wait. No, I don't see it, man. Hopefully it didn't fall off on the sidewalk somewhere. I don't see it, brother. What color is it? Yeah, I don't see it. Is it hiding down here? Yeah, there it is. Magic. There you go. All right, guys. Let's see. 1F.
My phone will up.
Did a whole slew of people just leave?
Yes.
Did they get answer keys?
No.
Good. Sorry. Yeah, just said.
Their fault.
Yeah. Yeah. Good luck. Okay. So this is an order operations problem. Everything is an order operations problem in math because it's the background of everything. But this is a very explicit order operations problem. What are you going to do first?
I'm going to go 0.2 twice.
4.
And,
1-0.
Because you're going to go back once, twice.
but I thought if it's the, oh yeah,
Because remember, this is 2/10, right? That's 2/10,
Right.
right? And this is 2/10. 2/10 times 2/10 is 4/100ths. That's why for every place in each number, it's going to contribute to the total number of times you got to go back in the answer.
Okay.
So 0.04.
Take that back 27, just make that.
But on the other one, you put a 10 and it was a 1.4.
Totally.
But if you have to put the zeros on the other side.
I want you to make whenever the top number is bigger than the bottom.
Oh, okay.
10 goes into 14 once with 4 left over, so it is 1 in 4 tenths.
Okay.
So that's the weird thing. So if I had 380 over 10, that would be 38.8. 388 over 100 would be 3.88.
Okay, yeah.
Because there'll be a whole number left over. If it was 100, it's 3 divided by 100 is 3. So it should be 3 point something. And it's going to move it back once, twice. Cool. So when the top number's higher, it kind of, it's a little bit tricky, so you got to be careful about it.
Yeah, I have a question.
Yes.
Does it matter if you put a 0 in there?
You mean that 0 there?
It does not matter.
Doesn't matter. But the reason we do that in general is just so we don't lose that decimal place. If you don't do it, I'm not going to take points off, but we're right where we are. So now we're here, right? We figured that out to be that. Now what's next? Subtract.
And then you give them.
They're opposite signs, right? So I do subtract, but I do 1.84 minus 0.04.
Yeah, we line them up when we subtract
I
them.
love it. Line the decimals up. But see how I turned it around so that, don't worry. What is 1.84 minus 0.04? 1.80. But which one's bigger? The negative one. So now I've got negative 1.8 over 0.3. Let's stop there for a second. Is everybody with me? How do you... Sorry?
Which one was the negative?
The bigger one. Alright, now you ready, guys? How do you do 142 minus 217? How do you do that? That is something we definitely should be able to do. Exactly. When you're trying to subtract a bigger number, screw that. I can't do that. I can't take a bigger number away from a smaller number. I can't. I'm going to end up negative, and I'm not sure how to handle that. So what I do is I say, well, how far apart are these numbers? And then it's going to land on the negative side or the positive side, depending on which one was actually bigger. So they are a certain distance apart. I can find how far apart they are, but then that answer is going to be either positive or negative based on which one was bigger. Yeah. So if I do that, so what am I doing here? That one's bigger than this, so I'm going to change them around. I'm going to subtract them this way, and then the answer is going to be the same sign as the bigger number. It's the same way we were doing before. Same exact thing we were doing before. You had to do problems like that before. Yes, you did. So I'm not doing anything different. Just because it's got decimals in it, that I can tell that's bigger. So I'm going to do the same process. I'm going to subtract, and then put the sign of the bigger one on. Otherwise, you're like trying to, if you do this, I'm certain somebody's going to be all, well, I got to borrow, and how do I take away from, there's nothing here. Do you see that? That is weird. Very strange. So screw that. Let me do this, and then just put the right sign on, and then I'm done. Maybe. Maybe. A little bit? Okay. And then what's nice about this, I don't know if you guys realize I can use the same trick we used before in a different way. Okay? So it's just negative 18 divided by 3. Negative 6. You guys see that?
So 4 minus 4 is 0, right? So there's no 0. There's only 1.8.
And what's 1.80 equal to? It's equal to 1.8. 1.8 equals 1.80 equals 1.80. All the way around the room. right? Come on now.
It's still correct, right?
Yeah, but you don't write unnecessary zeros unless I'm talking about cash. You wouldn't tell somebody, yeah, it costs 1.9. You'd say it costs $1.90, wouldn't you? Since it's based on out of 100 pennies, right?
Yeah.
So I would add a zero if I'm talking about money, but if it's just a number, I'm not going to say 1.90. What the? Right? It's 1.9. Yeah. Now in science, to be honest, if they say 1.90, they're telling you that they're more sure about what they measured. They add zeros to show how certain they are. So if you do this, you're like, I'm really sure about it, you know. But in math just says that's freaking 1.9. What's your problem? And we're in math right now, so I don't need these extra zeros. Now if you put them, I'm not going to take points off. I'm just going to go, why? Yeah. How's everybody? Is everybody? Yes.
So it's negative 6, you just drop the decimal.
No. I'll make sure you guys understand. So this is negative 1.8 over 0.3. Now how do I divide decimals? Don't I move the same amount, top and bottom? And then it's, what's negative 18 divided by 3? Negative 6. Don't think in your brain, oh, I did something with a decimal, so now I got to change it back. No. This is the same problem as this. These are the same problem. 6 times 3 is 18. 6 times 0.3 is 1.8. So either way you look at it, the answer is negative 6. So don't think that